Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 334. Find the maximum number of marked indexes. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So the core part, hard part about this problem is that it is a greedy problem. And with all greedy problems, there are also a lot of different ways of doing it. Most of them incorrectly even. And so the hard part is proving it correct. I must disclose that I don't remember this problem precisely, but I feel like I've seen it before, which lets me have an intuition to kind of deal with this. But the idea is that, so in my head, I kind of when I first saw this problem though, I kind of thought about it two ways, right? It's going to be greedy. It has to be greedy. Spoiler alert. And then there are really only two ways that I imagined initially of lining them up, right? So let's say we have, let's say they're all unique numbers, just make it easier, right? Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So one way to line them is 1, 2, 3, 4, 5, and then zigzag the other way, or not zigzag, but going back the other way, right? So that was, and here, what I did was that I assumed that if you're able to sort it, then you could probably take advantage of some greedy structure of the ordering of the things, right? So then I thought there was only really two ways. It's either this, or, well, the more preferred way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Like so. So basically, you're trying to match the smallest and the largest by breaking it in half. There are a couple of edge cases that comes in here, but that's basically the idea, right? In a greedy way, because and this is actually a terrible case for it. Let's change this to 5, 5, 5, 5, 5, because the idea here is that here, if they the intuition behind greedy is that, okay, let's say I have this array, right, or these two arrays lined up like this. If we remove the two biggest number, and assuming that we can, by marking them, right? One is double the other as per the problem description. If this is the case, then you could match them, and you can make the argument that there's no other, like every other exchange is going to be worse if you don't do this, right? You can kind of use the exchange argument. That's just for yeah, let's convert this to, I guess this is fine too, but the 5 is a little bit weird. Let's say we have something like this, right? I don't know. The idea is that if we switch this one with this one, or let's say, we look at the last two pairs of numbers instead, and we match the 10 with the 4. And of course, if these are sorted, and okay, fine, let me rewrite this so that in case if this is sorted, then this large number and this number is more than twice this number, that means that it is more than any other number, right? Of course, because it is sorted decreasingly. So that means that 10 could match with any of these numbers, assuming that 10 could match with 5. However, if 10 matches with a 4, for example, well, this 7 can only be worse, or any other number that matches with this number can only be worse. So that's basically a sort of an exchange argument that I made in this problem, and that's basically the way to do it. And you can kind of use that same-ish logic for, you could use the same logic for different kind of variations of what, you could, maybe this is a 9, and then it doesn't actually change anything, right, for example. But it can only be worse, actually, 10, say, right? Yeah. And then the only other edge case that I thought about was, what if there was an odd number, right? So then let's say we have 5 numbers. So it can only either be this case or this case, right? I think it actually doesn't matter. I think I was trying to get this to be here because that if this number is less than twice this number, we can match this with this anyway. Like if this match with this, let's say this is a 2 actually. if this matches with this, then this matches with this anyway. Everything just shifts over by 1, so it doesn't matter. And if you have a number that's too big on this side, then you would just remove this number and then try the next number anyway. So it also doesn't matter. So yeah. Oh, I think I did skip a case where basically, well, what happens if the first number on the smaller half is too big, right? Well, in that case, you just remove that number, because you know that if this number is too big for this number cannot match with any number on the bottom half. So there's no use of trying, so we remove it. And of course, in this case, you cannot replace this number with any numbers in the bottom half, because by definition, this number is smaller than every number, or equal to in this case, every number on the bottom half, right? So that's basically all the cases, I believe. If not, let me know in the comments, and or like, you know, maybe maybe check it out, I suppose. Yeah. That's all I have for this one. Let me know. Oh, wait, what am I talking about? Let's look at the code. So I'm really distracted because people keep on messaging me. I need to turn off my phone. I said that before, but okay. My fault. I am usually better about this. But okay. So yeah, first we sort the number, and then I just I probably could have actually sort reversed. But anyway, I do take the first half, reverse it, and then put it in the deck, so just so that I don't have to worry about indexes and counting and stuff like that. Same for the second half, and then basically it's just what I said, right? So the left half is the smaller half, and the right half is the bigger half in my code. So if this is big enough, then we pop the left, pop the right, increase the answer, and then continue. I actually probably just should have been add 2 because it matches 2 numbers, but I just multiply by 2 at the end. Otherwise, if this is not true, hence to continue, we just pop the one on the left, the smallest half, because like I said, you can match any numbers in it. It's basically the idea. Cool. So what's the complexity, right? It is dominated by the sorting, this linear space and linear time on these. These are also linear time and linear space. Well, I mean, space, I guess we already allocated, but it's linear time because obviously each number can only be popped once, so this is at most linear time, right? But it gets dominated by the sorting, which is n log n, and also space linear. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health, and you can watch me solve it live in the contest next. Different. It's like maximum bipartite assumption, something like that, kind of. But Oops. Did I do the math? Oh, this is this times 2. Okay. Oops. YOLO. There may be an edge case. Okay. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this explanation, and this contest. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.